Right, so this is 2003 question 22. Two skaters are joined together. So if you look at the diagram at the top, they start off together, travelling, so their mass is joined, okay, and they have a velocity each of 2.2 metres per second. And just so we can scroll that down, that's that there. Now, the mass of skater R is 54 kilograms, the mass of skater S is 38 kilograms. Skater R now pushes skater S with an average force of 130 newtons for a short time. This force is the same direction as the original velocity. That means that it's positive, okay? It's positive because the initial velocity was positive. Then it's saying, as a result, the velocity of the skater S increases to 4.6 metres per second. Now, if that velocity of that skater increases, then the velocity of the other skater is going to decrease. Conservation of momentum. You should have that idea in your head, just so if you get the wrong answer, you can know what you've done wrong. Calculate the magnitude of the change momentum of skater S. Impulse equals change momentum. Impulse equals Ft. Ft equals mv minus mu. You will find that in your data book. So mv minus mu is change in momentum for skater S. Just for skater S. So mv is 38 times 4.6. mu is 38 times 2.2. Do the subtraction, you get an answer around about 91. I'll show the answers in a second. How long does skater R exert force on skater S? Well, you know, to cause that change in momentum, there has been an explosion. Okay, they have exploded. Okay, the guy there has been an explosion. The male skater has exploded and pushed the female skater away. Okay, right. So there has been. So there's only ever explosions or collisions. Okay, so this explosion has caused the change momentum in skater S. That cause in change momentum has been due to the force times the time, due to the impulse. You know the force applied was 130 newtons because it's in your question, which is here. So therefore, the time in contact will just be Ft equals change momentum. So impulse equals change momentum. So use your answer from A, and you say Ft equals that answer from A, and work out T. Right, part C. Calculate the velocity of skater R immediately after pushing skater S. Right, your formula for momentum is M1 V1 equals M2 V2. Right, now in your data book, who's got one handy? Jay's got one. Right, so you're not actually given that formula in your data book. All you're given is that momentum equals mv. So this is one of these forms that's not in your data book. So the one that's not in your data book is that m1 v1 equals m2 v2. Now, what this formula means, it's not that the momentum of one skater equals the momentum of the other. It means the momentum before the collision or explosion equals the momentum after the collision or explosion. So this is before equals after. So before they are joined, they have one mass, they have one velocity. After, they are separate. So they have two separate masses, two separate velocities. So it's going to be the 54 times, not 54, 54 plus 38 times 2.2 to start with. And then it's going to be the separate masses and velocities. So you're going to have two of these after. That's going to be the mass of one skater and velocity of one skater. That's going to be mass and velocity of the other skater. You must take them separately to get, and what you're looking for is probably, if this is for skater R, you're looking for this velocity in here. So you just rearrange to get that one in there. You should be able to do that. Is this interaction between the skaters elastic? You must justify your answer by calculation. So it's 3 marks, so you get 1 mark for saying is it elastic or not, and then your 2 marks for working it out. An elastic collision. What justifies an elastic collision, Alice?
It's when the total energy before is the same as the energy after.
What type of energy?
Kinetic.
Kinetic energy. Total kinetic energy before equals total kinetic energy afterwards. Kinetic energy equals a half mv squared. You can do that for before, where they're joined. You can do that afterwards, or when they're separate. And if they add up, they equal each other, then it's conserved. Therefore, it is an elastic collision. If they're not conserved, it is inelastic collision.
You have to
calculate half mv squared for joined, and then as separates afterwards. And then add the separates together. Yep. Okay, right. Oh, it's not that bad. Right. Okay, I'm going to give you another 5 minutes. And then I'll come around and see if anyone else is still struggling with that. You get you 5 more minutes, and then we'll hopefully be able to just go through the answers for this. Okay, right, so let's just run through the answers to this one. 2003. Okay, so change momentum. Your finding should be change momentum is 91 kilogram meters per second. Except NS, which is Newton seconds, but not newtons per second. Okay, 91 kilogram meters per second.
Not newtons per second.
Well, it's round to 91. There's only 2 significant figures in the question, so
Allow for 91.2.
allow for 91.2. Yeah, but I'm just saying the answer is displayed as 91. But you can allow for 91.2. Okay, Moses
so
can
you lose
do
half a mark for newton seconds.
No, newtons per second. You can get newton seconds, but not newtons per second. Right. Then you have to calculate your time. Look, force times time equals delta mv, which is just what you calculate. You rearrange for 0.7 seconds. That's surely an easy mark. Easy 2 marks to get.
What if you put force time equals impulse?
Right, and then you said impulse was 91.
Yeah.
Well, that's wrong. Impulse is not 91. The change in momentum is 91.
It's impulse equals.
So you wouldn't get, so that would technically you've substituted into the formula for something that was incorrect.
Impulse equals. Impulse.
Yeah, but he said Ft equals impulse, and then he says impulse equals 91.
Ft does equal impulse.
Yeah, I know,
Impulse
but
does
okay,
equal 91.
right, okay. I get you. I know what you're saying. You probably wouldn't get that many marks off, but if you're saying 91 is change in momentum, that's what you've calculated. Yes, it does equal impulse because that's the formula. But what you calculated in question A, part A, was change in momentum. So all I'm saying is try and be as clear as possible. If you said impulse equals 91, well, technically you've not calculated impulse yet. You've only calculated change in momentum.
Which is impulse.
Right, don't argue with me about it. I'm just saying, I'm just being pernickety. Please, I'm just trying to get you to be as accurate as possible. Alright?
So if you said impulse equals change momentum, therefore
Yeah,
change
that's fine. That's
impulse
fine.
equals that.
Yeah, because you have calculated change momentum, it'd be nice to carry that on, okay, and say change momentum was. Right, anyway, time is 0.7 seconds. Right, then it goes on to total momentum before equals total momentum afterwards. Momentum before, now it's done the same idea, you just taking them separate, and then again taking them separate, you should get 0.51 meters per second, just like I showed you to do in the question. That's the way you should be doing it. Okay, this is all additional stuff. Right, and then D, you're working at EK before, you're working at EK after, and if they're the same, then it's elastic. If they're not, then it's inelastic or not elastic. EK before gets you 1.5 marks, EK after gets you half a mark, and then to say it's not elastic gets you 1 mark.
Ah, sugar plum.
And then to, interaction is not elastic, so it's 1, 2, 3 marks for that. Okay? Any questions about that so far? No?